Hi everyone, my name is Rafael and I'm going to talk about muscular action and posture balance after stroke, a computational study with modeling. But first of all, I want to introduce you a little bit about what is going to be inside of this presentation. We are going to discuss about the relation between stroke and the technology, especially because a lot of studies inside of motor control has showing a lot of interesting results related to how the central nervous system controls the body after some neurological disease, especially stroke. OpenSync is an open source software developed from Stanford community and have been used in several areas, but even they have been using this a lot. It's not consensus that it is real. The results are created and reliable. Muscle model is essentially important here to work with simulations that tend to work with posture because we need to recreate some biological and parameters that are closer to the reality. So because of this, we have two different objectives that are compare the joint moment calculated in OpenSim with that produced by Nexus 2.7, and the second one it is to establish one contraction muscle model in OpenSim that can be integrated with the mathematical model that we'll be using in the major project of the professor. So the joint moment are the variable that we choose to compare the outputs of it. It can be calculated and compared between the outputs of from the two softwares, Nexus and OpenSync, throughout some kinetics calculus. So here we have the calculus of one stroke patient, one individual that had stroke, and we used the same data from the two softwares, and here we can see the difference between the patterns of the joint moments produced from the right and left side. Especially the right side, we can see a different and noisy pattern of the joint torques and joint moments that can be a result from the spasticity process. But here in the OpenSync, and it's not clear that and we can't say this because it's a very noise signal and we can attribute it to the spasticity process it, and we just are asking to ourselves if this can be some problem inside of our collect record of data or something about the calculus that we get wrong. About the muscle tendon unity, we choose one heel type muscle model from and the parameters we choose from the Song and Geyer from 2015, and that had some problems and that we solved to recreate an inside of Simulink environment that works perfectly right now. In the future steps, we hope that we can work with a specific data from OpenSea and implement the muscle model from inside of put inside of OpenSea. I hope that you like the presentation and see you guys soon.